Hi everybody, good to see you all again. So today what we're going to be doing is we're going to review a little bit of what happened in the previous lesson and also move on to the other stuff here. So note that in this situation we can start off with a portion of a circle here. You'll note that I decided not to draw the entire circle, and you'll see why in a bit. So we have a circle radius 6 and you have AB here and you have this arc. Note this is a 45-degree arc. So it's not hard to calculate the length of A to B here, what this length ought to be. Right? We can figure this out here from yesterday, from the previous lesson here. We know that our area for our formula here was the central angle x over 360 times 2 pi r. So we can go. So we're going to use this formula in a bit. So I'll do that down here. We can see that this is going to be 45 over 360 times 2 pi times 6. And that's, well, let's see, 45 over 360 is 1/8, so you have 1/8 times 2 pi times 6. You can see that there's a bunch of 2's that cancel out, in fact, so this 2 cancels this 8, leaving a 4. This 6 cancels a 4 here, leaving a 2 left over and a 3 here. So we're left with 3 pi over 2. And we can see here that in this situation, the length of this arc is 3 pi over 2. Now, of course, that's all, now that's all fine and dandy here, but it doesn't tell you much about the area here. We can also try to calculate the area of this entire thing here. So basically the entire thing in blue here that's bounded by the radii and the arc here. So this is known as a sector, ladies and gentlemen, because it's bounded by 2 radii, AO and BO, and also the arc on the outside here. Now, finding the area of this object shouldn't be too hard here. Again, we're utilizing that. If you think about this 1/8 thing here, we see that 1/8 is going to work out pretty well, right? That 1/8 came from the central angle divided by 360. So we can do much the same thing here. So this was our arc length formula here. It shouldn't be too hard for us to do the same thing here. We saw that this was a fraction here. Right, there's the fraction of the circle here. So we're still going to need that. Definitely, it makes sense for us to do something like this here. Where we're going to have the fraction of the circle again. We're going to have x over 360 pop up again here. Now note that because we're not finding an area, we're finding the area now as opposed to a length. Now we're going to do this entire thing here. So this is going to be a 2 pi r, and this is going to be the area of the circle. Now, some of you may remember that this area of the circle is pi r squared, and we can do that here too. So we can do x over 360 times pi r squared, and that's going to be our sector area here. Okay? So you can see that in this situation here, we can have an analogous formula like so, where you have x over 360 times pi r squared. Now, this is probably, pi r squared is probably one of the most ubiquitous formulas out there. Certainly you've seen this formula before, certainly you've heard of the formula, but some of you may not know why the formula actually works here. So I'm going to give you sort of a brief idea as to why that works. Now, some of you, maybe you're watching this around lunchtime or something like that, and you might be getting kind of hungry. I mean, I'm kind of hungry myself. It's almost it's 12:30 here, so I do need to get some lunch. But, I'm reminded of pizza here. So you can actually do this with a pizza, or, if you don't want to buy a pizza, you can actually do this with an orange at home. Note that when you cut through an orange, right, you're going to get something that looks like this here. Right? And with an orange here, usually it's going to be cut into 8 sectors. So you're going to see that you can actually have something that looks like this here. So if you have an orange or a pizza, you can do this here. And then what you can do is you can rearrange it so it looks like this. Okay, so we're going to get a picture that looks like this here. And I'm sure you can find another picture of this online that's better than mine. Oh my god. So aside from the fact that this looks like really awful looking teeth, I'm sure my dentist would be proud, this also kind of looks, if you think about it, it looks very much like a parallelogram. Now, granted, I know this is not a parallelogram because it's all curvy and I have this really weird thing up here, but it kind of does look like it, right? Notice that we only use 8 slices here. If I decide to use 16 or 32 or 4,000 or even 10,000 slices, this will get closer and closer to that of a parallelogram. So the area of this is just the area of the circle is just the area of this, because all I did was just take the slices, the sectors, and just sort of stack them like this here so they interlock, like so. All right. Now, this is a parallelogram, so we can try to find the area of this object. Now, in order to find the area of a parallelogram, that's just base times height. The height of this is pretty clearly the radius, because that's just the slice here, and all these are the radius here, so we're going to say that's the r. That's the height. So the height, in this case, is r. And what it is down here, note that in this situation we need to figure out the base. Now this base, if you think about it, this is actually the sides of half the slices here. So half the slices are going to be around like this. So you have this, and this, and this, and this, corresponding to these pieces here. So it makes sense that it's going to be half the circumference. So it's going to be half of 2 pi r. Okay? So now we can actually put this together. We can find that the area of the parallelogram is going to be the base, which is 1/2 times 2 pi r, times the height, which is r. And you see the 1/2s drop out, and we have 2 r's here. So that yields us pi r squared.